All right, let's do some practice problems with the ideal gas law, PV equals nRT. Here's our first one. 2.3 moles of helium gas are at a pressure of 1.7 atm and the temperature is 41 degrees Celsius. What is the volume of the gas? The first thing that let's do is get our variables straight. Now here I'm going to be using R, which is a constant, so it doesn't have anything to do with this problem. It's just always here. Now maybe your teacher or your textbook has given you another value for R that isn't 0.0821. If that's the case, still watch this video, but then watch the other video that's called What If R Isn't 0.0821, and that should make everything clear. Okay, so anyway, R is right here. What's the volume of the gas? V is going to be the value that I'm solving for. Now let's plug the other ones in. All right, so we have a pressure of 1.70 atm. We have the amount of gas is 2.3 moles, and the temperature is 41 degrees Celsius, which you probably already know we're going to have to end up converting to Kelvin. Okay, so let's go ahead and do that right now. To get to Kelvin, we take our degrees Celsius, which here is 41, and we add 273 to that. So temperature will be 273 plus 41. So we're going to end up with 314 Kelvin. Now is a good time to look at these variables up here and compare their units with the units on R. We want them to be the same. Okay, so ATM's up here, ATM's down here. That's good. Moles here, moles there. Kelvin there, Kelvin there. All right? If any of the units were different than what they are in R, we would have to convert them so that they were equal. So for example, if pressure were 1.70 kPa, and we have ATMs down here, we'd have to convert kPa into atmosphere so that it would be the same as the units on R. All right? Keep that in mind for the future. All right. So we know we're solving for V. Let's go ahead now and rearrange the equation. We want V to be on one side all by itself, so all I've got to do is divide both sides by P. And in that case, I have P up here and I have P down here, so they're just going to cancel out, and I'm going to be left with V equals N RT divided by P. There's the equation, all right? Now, R. Let's talk about R for a sec. R is such a pain in the neck because it has two parts, right? It has a top and it has a bottom. How do we plug this thing that has both a top and a bottom into the top of a fraction? Okay, there's no really good way to do this. Some people do it and they make like a triple-decker fraction, which I hate. I think that's so ugly and it's far too confusing. I'm going to show you a way that I like to deal with R that may be different from how your teacher or textbook tells you to do it, but bear with me. I think it's actually a pretty good way to do it, and I think it certainly makes the units clear and how we set everything up. So I'll show you what I do there. Just to make space, I'm going to move this up here. And now I'm going to take these variables and I'm going to plug them in, okay? So I'm going to do V equals N 2.3 moles. And as I said, when we get to R, I'm going to leave R until the end, okay? So I'm going to do N, then I'm going to do T, times T, 314 Kelvin, divided by P, 1.70 atm. Now I said I was going to leave R till the end, okay, so let's go back to R, times R, 0.0821 liters, atm, Kelvin, moles. All right, the reason why I left it till the end is then we can put it all the way here and we don't have to worry about putting it on top of this fraction, okay? But since these are all multiplied together, it doesn't matter what order we put the nRT in. So I just put R last, it's no big deal. All right, now I have all my units set up here. This is so satisfying to go through and cancel them, okay? Moles up here, moles down there. ATM down here, ATM up there. Those cancel out. Kelvin up here, Kelvin down there. All right? Which means that I'm left with only liters, and that makes sense because I'm solving for volume. Okay? Now it's time to put all this math into my calculator. I'm going to do 2.3 times 314 times 0.0821, all of that divided by 1.70. The answer that I'm going to get is 34.87801. All right? How many digits do I round this to? Okay? I look for the number up here that has the fewest significant figures. That's here, 2.3 moles, which means that my final answer has to have two significant figures. So I keep the 3, I keep the 4, and I look next door to the 8 to see whether I round this up or keep it the same. It's an 8, so I'm going to bump it up. So 34 point blah, 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 blah is going to turn into 35, rounded to two significant figures. And what are my units? I know what my units are. My units are liters because everything else here canceled out. So 35 liters is the volume of the gas under these conditions. Okay? Let's take a look now at what happens when R is on the bottom of the fraction. So we'll do a similar problem, but I'll show you how to deal with R in this situation, okay? And what I'll do is I'll just go ahead and fill in these variables as we go, all right? At a certain temperature, 3.24 moles of CO2, so that's our N, how much gas? 3.24 moles of gas are at a pressure of 2.15 atm, and they take up a volume of 35.28 liters. What is this temperature in Celsius? Okay, so T is going to be the variable that we're going to be solving for. Before we go ahead and rearrange this, let's again look at the units of all the variables that we're going to plug into the equation. Do the units up here match the units on R? ATM, ATM, liters, liters, moles, moles. Okay, we're set. Just once again, if the units here didn't match the units on R, we would have to convert them so that they did match. Okay? In this case, we're going to be solving for T. So to get T by itself, we'll divide both sides by N times R. The NR up here and the NR down here are both going to cancel out, so we're going to be left with PV divided by nRT equals T. I know that some people don't like it when the variable we're solving for is on the right side, so we can rearrange this to T equals PV divided by NR. Let's go ahead and plug these variables in. Now here R is on the bottom. I'm going to show you what I do with that, but we're going to leave it till last, just like we did before. Okay, so T equals pressure, 2.15 atm, times volume, 35.28 liters, divided by N, which is 3.24 moles. And what I do when R is on the bottom is I take R and I flip it upside down. Okay? So what is normally on the bottom, Kelvin moles, is going to be on the top. And what is normally on the top, 0.0821 liters atmospheres, is going to end up on the bottom. Okay, so again, I leave R till last. All I do is I flip it. If R is on the bottom, I take the normal value of R and I flip it upside down. Okay, again, I love this. It's so satisfying, all right? I go through here and I cancel my units. ATM up here, ATM down here. Oh man, doesn't that feel good? Moles down here, moles up here. Cancels out. Liters up here, liters down there. I'm left with Kelvin, which makes sense because I'm solving for temperature. So my final answer is obviously going to have the units of Kelvin. But canceling out all these other units and being left with just the units I'm looking for also lets me know that I went ahead and I set up the equation correctly. Okay? So I plug through all these numbers, and the final answer that I'm going to get is 285.1536 Kelvin. How many digits do I round this to? Okay? 3 significant figures for most of these, 4 significant figures here, but I always have to go with the fewest. So I'm going to round this to 3 significant figures. Keep the 2, keep the 8, keep the 5, and look next door to the 1. Do I round it up, keep it the same? I keep it the same. So it's going to be 285 Kelvin. But we're not quite done yet, because if you remember, the question asked, what is this temperature, not in Kelvin, but in Celsius? So the last thing that I've got to do is I've got to take this Kelvin temperature that I had and convert it back to Celsius. According to this equation, to get a Celsius temperature, I take the Kelvin temperature and I subtract 273. So here's my temperature. 285 is my Kelvin temperature, minus 273. And that is going to give me 12 degrees Celsius. And that is my final answer.